So for 1.1, so let's see, for homo 1.1, you're gonna need the formula for the area of a triangle is 1/2 base times height. If the triangle is a right triangle, then the base could be a leg and the height will be the other leg, okay? Okay, so let's see. Yesterday we were doing 2.1. Let's see if we finish 2.1. I think we did the domain. Yeah, we did find domains. And that was office hours. And we did the function notation, okay. So we did function notation. So continuation of 2.1. So, so we know what a function is. We know what a, so we had the definition of a function, right? How to recognize, and if you have to the graph, how to apply the vertical line test for functions, how to find the domain. Okay, so now we're going to start with operations with functions. So basically we have these functions, and then the next question is, can I add, subtract, multiply, divide these functions? Okay, so and the answer is yes, but the main thing you gotta make yourself comfortable with here is the notation. The rest is basically the usual algebra. Okay, so let f of x and g of x be two functions with corresponding domains. And let's call, so we're using uppercase D for domain, but I cannot do uppercase D for f and g. I have to have a way to distinguish them, so you put a subscript. So the domain for f would be uppercase D with the subscript of f, and the domain for g would be the uppercase D with the subscript of g. Okay. Okay. Then 1, the sum function. The sum function is the function obtained by adding two functions. Okay, so the sum function is a single function. Now, to emphasize that is a single function and not two functions, is the notation is f plus g of x. Now, how do you obtain this? By adding f of x and g of x. So f plus g of x is f of x plus g of x. So for example, if f of x is 2x cubed plus 4x, and g of x is 1 over x minus 2, then f plus g of x is f of x plus g of x. That is 2x cubed plus 4x plus 1 over x minus 2. So you just add the two functions. So again, the struggle at the beginning is just with the notation. So f plus g of x is really the sum of the two functions, f of x and g of x. Okay.
Can you repeat that by any chance?
Yes. So this is what I repeated. The sum of the sum function is a function obtained by adding two functions. So, okay, so the way you read this, you read as f plus g of x is f of x plus g of x. Does that help?
I think so, yes.
Okay. So, so this is my equal sign, okay? And then similarly, we do with the difference, the product, and
unknown caller. I have a question, Professor. On the exam, are you gonna have like the sentence written out like that, and then you're gonna ask us to write it in mathematical form, or why do we need to know that?
No, in the exam, I'm gonna say, okay, let f of x be that, g of x is that, fine, f plus g of x. So all the things that are circled in green, those are the givens. So let's do the other one in light blue. So then you will say, oh, this is equal to f of x plus g of x. And then you substitute and you say, oh, f of x is 2x cubed plus 4x plus g of x is 1 over x minus 2. Okay?
Okay, thank you.
Very good. Okay. Yeah, I forgot to change color. The difference. The difference function. Is the function obtained by subtracting. Two functions. So it's very much like f plus g, but there's a difference, so it will be f minus g. So f minus g of x equals is obtained by subtracting f of x minus g of x. So you read that f minus g of x is or equals, so for variety, let me put equals f of x minus g of x. Okay. So if I'm looking at the functions, use f and g above to find f minus g of x. Then you will do f minus g of x is f of x minus g of x, and then you substitute it. 2x cubed plus 4x minus 1 over x minus 2. So sometimes you might have to take a step further and simplify, but in this case, there is nothing to simplify. Okay. We have to talk about the domains also. So what is the domain of the function f minus g? Well, since the function f minus g is obtained by subtracting f of x and g of x, then whatever you plug in for x, right, you have to be able to find a y for f and a y for g. In other words, x must be in the domain of f and in the domain of g. So the domain of F just says that for these numbers, I can find a Y under F. The domain of G is for these numbers, I can find a Y for G. So, and that is denoted as the intersection. Domain of F, intersection, domain of G. So then in set notation, it's a set of all x's, so that X is in the domain of F. And at the same time, it has to be in the domain of G. Okay, so in the above example, find the domain of F minus G. So then remember F of X was 2x cubed plus 4x. It's a polynomial. There is no restriction in any of the operations involved here. That is addition and multiplication. So then the domain is all reals. So domain of F is all reals. Or that.
Can you repeat? Can you go back to the line where the arrow goes to?
This part?
The D, yes.
Yes. So what I'm saying here is, let me make a little more room. Okay, so I'm reading this one. You read as the domain of F minus G. Okay, so the domain of F minus G. So in the example, is equivalent to saying, well, what is the domain of this function, right? Because this is the F minus G function. But instead of looking at this as a function by itself, which is one way of looking at it, the other way of looking at it is by saying, well, what's the relation? Since this function comes from subtracting two functions. So what's the relation of the domain of the final function in terms of the domain of the functions F and G that make up the final function? So then we say, well, in the relation is that because these two functions are being subtracted, then when you plug in a value for X, I should be able to calculate the F of X. I should be able to calculate the G of X. So then that means that it has to be in the domain of both.
Okay, so it's domain F. What's the sign?
This one means intersection. And the intersection means it has to be in both. Okay, I have to be able to calculate F of X. I have to be able to calculate G of X. If I cannot calculate one of those, then it cannot be in the domain. And the intersection always goes with the and. Okay, so the and means it has to be here and here at the same time. Okay, so those are technical terms, yes.
Where did the E come from? Is it an E, X,
Oh,
E?
that's another symbol, yes, thank you. That's another mathematical symbol. And that E is special, and that means it's an element of the set. Or you can also say belongs to the set. So then when we read this, we said X is an element of the domain of F, or X belongs to the domain of F. You read that at X is an element of D of F.
So how would you read that? Df, the domain of function f minus g equals df.
Equals domain of f minus g equals domain of f intersection domain of g. Okay, so I seem to be moving below. Okay. So domain of f minus g equals domain of f intersection domain of g. And then I can continue, which equals the set of all x's. And this vertical bar means so that, or with the condition that x is an element of the domain of f and x is an element of the domain of G. So that's how you read that whole string. So yes, mathematics is a very compact language. And so mathematicians don't like to write too much. So start involving inventing symbols. So then you get a something more compact, more concise with very few words. Okay. Anything else that I might miss? Yeah, this is important because if you understand the language, then you understand what they're trying to tell you, right? So this getting familiar with the symbols is the first step. It's like learning a new language. You have to learn the vocabulary, the rules. So this is the vocabulary, right? Those symbols. Okay. Any other questions? Shall we continue?
Yes.
Okay. So we were looking at, so we introduced the difference function and then the definition of the domain of the difference based on the domain of the parts. And so we have an example. So we're looking at the same functions, f of x equals, where is it? Here. F of x equals 2x cubed plus 4x, g of x equals 1 over x minus 2. And we're looking at the domains for each of the parts. 1 over x minus 2. 1 over x minus 2. So g of x equals 1 over x minus 2. So we said that the domain of f is all reals because there is no restriction in the kinds of operations involved to find f. What is the domain of g? So to find the domain of G, again, you look at the operations involved. There's a subtraction. There's no restriction with subtraction. You can subtract any two numbers. And there is a division. Is there a restriction in division?
Yeah, x wouldn't be able to be 2.
X cannot be 2. Because if x is 2, the denominator is 0. So you're saying if x minus 2 is 0, that means x equals 2. So the domain of G is the set of all x's, so that x is not equal to 2. So then I go and say, well, therefore the domain of f minus g must be the domain of f intersection domain of G, right? So it has to belong to both sets. Now, F doesn't have any restriction, so anything goes for F, but G has a restriction. So then that means the restriction of G has to take over because 2 doesn't work for G, therefore it doesn't work for the subtraction. Right, so what the two sets have in common is everything except 2. By the way, the domain of the sum is the same thing. So the domain of F plus G is also the intersection of the domains by the same reasoning. So domain of F plus G is the intersection of F and G. So in the example above, the domain of F plus G would also be everything except 2. Any questions?
Can you repeat that, please? I'm sorry.
No, that's fine. No need to apologize. The domain of the sum.
Yes, the equation before that. Like, how did you get to it?
How do we get
To
x
the-
not equal to 2?
Oh, okay. Because if it's 2, it's gonna be 0.
That's right. If
Okay.
it's 2, it makes G 0 in the denominator, so you cannot find a y value for G.
Okay.
Okay. Okay. Addition, subtraction, next is multiplication. Have I been numbering? Yes. 2 was the difference, 3. So the answer of an addition is the sum. The answer for a subtraction is the difference. The answer for a multiplication is the product. So the product function is a function obtained by multiplying two functions. So f dot g, f times g. So is the function f of x times the function g of x. Okay, so you read this as f times g of x equals f of x times g of x. Okay, so this times has to do with the multiplication. So example, and the domain is also the intersection. So the domain of f times g is also the intersection of f and g, because you have to be able to get to this point, get the number that represents f of x, the number that represents g of x, so that you can multiply them. Okay, so example, so f of x equals, I guess we'll do the same. 2x cubed plus 4x. G of x equals 1 over x minus 2. Find f times g of x. F times g of x equals the product of f of x and g of x. So we plug in. So f of x is 2x cubed plus 4x times g of x, which is 1 over x minus 2. Oh, yeah. So there's a question in the chat. Are we basically trying to find what is the restriction? Yes. To find the domain, because restrictions are, sometimes it's easier to find what is not in the domain than rather what is in the domain. So you find the restriction and then you take away what's not so that you can see what's left is what's in. Yes, somebody was saying something. So what is the next step? Let's take it one step further and simplify it. Maybe think of this as a product of fractions, right? And the way multiplication of fractions work is if you have a fraction AB and a fraction CD and you're being multiplied, so then this is A times C over B times D. Top, top, bottom, bottom, right? So then, identity, 1 is the identity, so any number times 1 or any expression times 1 is A. And of course, 1 times A is A. So 1 is the identity. So here we have 1 times 1. So then it's just that expression. And the denominator also 1 times that. So it's just x minus 2. So this becomes 2x cubed plus 4 over x minus 2. So that would be the product of these two functions. And the domain of the product is the intersection of the domains, which is what we calculated before, all the x's, so that x not equal to 2.
What does that upside down U represent again?
Intersection.
Okay.
Let me make sure that I got it here. Intersection means it has to be in both sets. Does anybody know what this means?
Union. Like a
Union.
Yeah.
Yes. And what does union mean? So intersection means it has to be in both sets. What is a union? Now, one way to express it is a collection of both sets. So then the way this is illustrated sometimes, say you have set A and set B. So then the union is all this with the intersection. Is what's in between only. It has to be in both. So that's the difference between the union and the intersection. Does that make sense?
Yes.
Okay, very good. All right,
Oh,
and
wait.
finally,
I had a quick question actually.
yes, go ahead.
Where you got x does not equal 2, where did that 2 come from?
It came from G. You see the denominator is x minus 2.
Yeah.
So then we were saying, well, if there's a denominator, that means I'm dividing. I cannot divide by 0. So I'm saying x minus, I find where x minus 2 is 0.
Okay.
And then you take out that point.
Okay.
Okay. Any other questions? Okay. Addition, subtraction, multiplication. Operation number 4, division. The answer to division is called the quotient. Quotient function. Oh, it's 11:50. Oh, class ends at 12:45. Okay, I was mistaken. Quotient function is obtained, or I guess I was saying is a function, or is the function obtained by dividing. Now you don't really divide, or you make a fraction of two functions. Okay, so you don't divide in the sense of long division or 60 bar by 3. So usually you leave it as a fraction. So the notation is you make a fraction with f of g, with f and with g, and then you put the x at the end. So f divided by g of x. So that will be f of x divided by g of x. So we read it as f divided by g of x is f of x divided by or over g of x. So the domain, now the domain, there is an extra condition here. So the domain of the quotient, because we have a quotient, we start with the domain of f intersection domain of g, right? Because I have to be able to get a number in the numerator, a number in the denominator. But in addition to that, I don't want the denominator to be 0. So then we're saying the domain of f over g is the intersection of the domains minus, that is, you take away all the x's that make the denominator 0. Okay, so this is the denominator. So the domain of the function f over g is the intersection of the domains minus, that is, take away all values that make the denominator function, that is g of x, 0.
What does it mean when it says the intersection of the domains? Like if we were to graph this, this is where they intersect, or?
Yes. So you see here, the intersection is what belongs to both of them. So there's green area, shaded area, belongs to A and belongs to B.
Okay, thank you.
Okay, so when we have been looking at the intersection, so recall, so the domain of f was all reals, right? You can also see this by looking at the real line. So the domain is everything here, all reals. The domain of g is all the x's, so that x is not equal to 2. So when I look at a copy of the real line, then I locate the 2 and I have to take that out. But everything else is shaded. So what numbers belong to both sets?
Can you go slower by any chance and repeat
Yes.
the full part,
Yes, I
please?
may. Okay. So I'm going domain of F and domain of G. I'm going back to what we already calculated. Okay. And the
Mhm.
domain of F is all real because it's just a polynomial. Domain of G is all x is not equal to 2 because of the fraction. You remember that, right?
Yes.
Okay. So now I'm saying I'm going to show you how to get to the domain, the intersection of the domains being not equal to 2, but we're going to look at it in a slightly different way, like sets. And so the domain of F is the set of all reals. Okay, you can represent that on a real line. So it's a real line and you shade everything. Okay. Domain of G was everything except 2. So I locate my 2 and I take that out. So there's empty, but everything else is shaded. Okay, so this is
Okay.
one set and that's another set. All these shades, the shaded regions are what's in the set. What is the intersection? What's in both sets? Is the number 2 in both sets?
No, it's only on the F.
Is only on the top. But because it's not on the second, then it cannot be in both, so it's not in the intersection. So I take out my 2, but everything else is shaded in both real lines. So then the intersection is this. So meaning all the x's so that x is not equal to 2. Does that make sense?
So everything but 2 is the intersection?
That's right.
Okay.
Okay, so let's look at this example. Say, I guess let's make up another problem. Example. Say f of x equals square root of x plus 2. G of x equals the square root of 2 minus x. Okay, so here we have two functions. And okay, so we were doing find domain of F, domain of G, and the domain of F intersection domain of G. Okay, so that we can understand the intersection. Okay, so here's where we're looking for restrictions. So f of x equals the square root of x plus 2. So so addition has no restrictions. So we concentrate on the square root. What is the restriction for the square root? Can you take square roots of any numbers? Can you take the square root of -4?
No.
No. So here is where we say we have a restriction for square roots, square or any even root. So if we have an 2 and then an expression inside, the expression inside is called the radicand. The restriction is the radicand must be greater than or equal to 0. Okay, so then I look at this and we say, well, what is the radicand for f of x? Is the expression within the square root. The whole thing is a radicand. X plus 2. So the radicand is x plus 2, and that must be greater than or equal to 0. It cannot be negative. So then we have an inequality. Isolate the x, subtract that 2. So x must be greater than or equal to -2. So then the domain of f is the set of all x's, so that x is greater than or equal to -2. Is that correct?
My bad.
Yes.
Yes, right? And if we're not sure still, well, let's check. Give me a number that is not greater than or equal to -2. Say -3. What happens when I try to calculate f of -3? So this is my function, square root of -3 plus 2. And what is the square root of -3? What is -3 plus 2? -1. What's the square root of -1?
Undefined.
Not real. Is actually somebody, in the history of mathematics, somebody said, well, what can we define this? What if we were to define the square root of -1? And that question gave birth to a whole world called the world of complex numbers. Now, the difference between this being not real and say having 7/0, which is undefined, is that literally 7/0 cannot be defined, because any number that you put as an answer times 0 has to be 0, right? So that's a slight difference, okay? So square root of -1, you can define it, but it's not gonna be real. And the other one is undefined. Okay.
That's
Okay, then, yeah, go
oh,
ahead.
it says restriction for square even roots.
Yes,
Okay.
square roots or even roots.
Oh, okay.
So if I say, if I were to have like the 4th root, then you'll take the same approach. The radical must be greater than or equal to 0. Any even root.
For any even number. Okay.
Yeah.
Wait, where
If
did the 4 came from?
I hypothetically speaking, because I was trying to illustrate the possibility of having an even root.
Okay.
Okay.
One question.
Yeah.
This is a function, right? And a function is defined as just having one y. But
Yeah.
if the number inside the square root is, let's say, 4, wouldn't the answer be -2 or +2?
No, they let's see. That's the difference. You see, if the question, so note, if I say find the square root of 4, then the answer will be, as you said, 2 or -2. However, when the question is written as with the radical notation, the radical notation is the symbol, means the positive. Okay, so that notation is safe for the positive root. So there are no 2 possible answers.
How do you know? How do you make the, how do
By
you stimulate
definition. This is a
Okay.
rule. Okay, so the answer is +2. One answer. So you will see some cases where you have plus or minus square root of 2 or square root of 4. Then here that means plus or minus 2. You see? That's why sometimes you see the plus or minus in front of the radical, because the radical takes only the positive root. Okay, very good observation. Any other questions? So then it's a function. Okay, so that's the domain of F. Now let's find the domain of G. So let me, since it's all the way up there, so G, let's copy G of X, which is 2 minus X. Okay, what is the domain of G? So notice is a square root. So what do we do when we have a square root? You look at the radicand, right? The expression inside the root, and that has to be greater than or equal to 0. So the radical must be greater than or equal to 0, meaning 2 minus x must be greater than or equal to 0.
So x equals 2, greater or equal to 2?
Are we subtracting? Okay, take me step by step.
2 or less.
What are you doing? Adding, subtracting the same side. What quantity?
Subtract 2.
2,
2 or negative 2.
2.
Add a 2.
No,
No,
subtracting 2.
Okay, subtracting 2. So then I get negative x greater than or equal to negative 2. And what's the next step?
Divide both sides by
X.
-1.
Negative 1. So what happens when you divide by a negative in an inequality?
It flips.
It flips. X less than or equal to 2. Very good. Okay, so this is the domain of G. Okay. Now let's look at the intersection of domain of F and the domain of G. Actually, let's put this down here, and then let's look at one at a time. So domain of F and domain of
Can you
G.
go up a little bit so I'll finish writing? Thank you.
Professor, in the case of negative x, when you flip the sign over, if it was just negative x greater to or equal to 2, would you still flip it over?
Yes,
Okay,
because you are dividing by negative, right? So
Okay.
then this has to change. So I
Thank
guess x less than or equal to negative 2. Yes. Dividing by a negative number. Okay. So then domain of G is x, so that x less than or equal to 2. Now let's graph that. So if my 2 is here, do I shade the 2? Is 2 included?
Yes,
Yes, so it's the square bracket. Is it gonna be the left or the right side of 2?
the left.
The left. So square bracket and then shade to the left. Okay, I'm scrolling up, looking up, and notice that domain of F is greater than or equal to negative 2. Greater than or equal to negative 2. So I draw my real line. So imagine it's at the same copy of that. So then if 2 is here, then negative 2 must be there. Okay, so do I include negative 2? I'm going to shade
No.
F now. Do I include negative 2? I'm sorry.
Yes.
Yes. Do I shade to the right or to the left?
To the left.
Is x is greater than
To the right.
negative? To the right. Very good. So square bracket enclosing to the right, and then shade everything to the right. Okay. What is the intersection?
Between -2, between -2 to 2.
Very good. So enclose there, and that is the intersection. Okay. So the outside there is one set that is not shaded. So the intersection. Now, how do we write an interval like between -2 and 2 as an inequality? So isn't it -2 less than or equal to x less than or equal to 2? So this will be the intersection of the domains. Okay, I think we got that down, right? The intersection. What does intersection mean?
Can you wait? Can you what does the bracket mean again? I forgot. Like that's where it closes, right?
These
It-
two brackets?
No. Like where the -2s are. Like that's
Oh,
basically saying it
yes.
doesn't go past that. Like a closed circle, pretty much, right?
Yes.
Okay.
Yes, some of you are familiar with the closed circle. It means that the endpoints are included.
Yeah. So would it matter if we used like a circle? Because that's what I was taught growing up.
That's fine.
Okay, cool.
Yeah, I'm doing the bracket because the book does the bracket.
Oh, okay.
But yes. And if they, so these are the same. If they are not included, if it's a parenthesis, then it's an open circle.
Yeah, I bet.
Yes, yeah, that's exactly correct. Okay, so now let's look at an example of, we don't have an example of the quotient. Right? So let's look at this f of f and g. So let, example, let f of x be square root of x plus 2, I think. And g of x was the square root of 2 minus x, right? Find f over g of x and the domain of f over g. Okay, so let me give you a minute to do this. So you're going to start with f over g of x is f of x over g of x, right? So continue from there. I'm gonna get a little water because I'm approaching, it's very hot. Okay, so what is f of g of x?
X plus 2 divided by 2 minus x.
And what are we gonna do with the square roots?
We're gonna add them.
Let's not forget them. Like that, right? Square root of x plus 2 over square root of 2 minus x. Any questions? Okay. So what is the domain of f over g? So we said back up here, where is my quotient? The domain of f over g, we start with the intersection, but we have to take one step further and then take away the ones that make the denominator 0, okay? We already have the intersection. So let's write the expression first. So is the domain of f intersection domain of g minus all the x's that make g of x equal 0. Okay, so the intersection we just calculated, and the intersection is the interval from -2 to 2, including -2 and 2. So then we have is the set of all x's, so that -2 less than or equal to x less than or equal to 2, minus all the x's that make g 0. There is the g function, right? That's the g function. What makes this g function 0? 2. So that's the square root of 2 minus x equals 0, square both sides, 2 minus x equals 0, and an x on both sides, so x equals 2. So we have to exclude 2. So I take, so this is my domain. That's my domain. And that's the intersection. And then I have to take out 2. So take that 1 point away. So then that means that this inequality, less than or equal, just changes to less. Is that correct? So then the final answer will be domain of f over g is the set of all x's so that -2 less than or equal to x less than 2. Just less, not less than or equal. There. Okay. So
I
any
don't-
number. Yeah,
I
go
didn't
ahead.
understand this. Can you repeat it, please?
Okay. So we have, because it's a fraction, right? Then the denominator cannot be 0.
Okay.
So the denominator is the g. So that's where I say g cannot. So take away when g is 0. So then that means that g cannot be 0. So then you say, okay, when is g 0? Well, g is square root of 2 minus x. So there's my square root of 2 minus x. When is the square root of 2 minus x 0? Well, you treat that as an equation, square both sides, so you get 2 minus x is 0, add an x on both sides, so then you get x equals 2.
Okay.
And you can also see it from the expression that if x equals 2, but it's good to do it algebraically because sometimes the equations, the denominator is a little more involved. So you can see that if I put a 2 here, I get 2 minus 2 is 0. So that's what I said, minus 2. So take away, so from this set, the interval from -2 and 2, from that set, I'm going to take away the point that corresponds to the label 2, right? So I look at the picture. So here's the picture. That represents the interval from -2 to 2. But I have to take away 2. So you take away this point. So that now is going to become an open circle or a parenthesis. So that's what this illustrates. So you see here, it says less than or equal to 2. Now it says less than 2 because of that part. So let's emphasize that by doing the picture. So -2 close, 2 open. Or with circles, -2 solid circle, 2 open circle. Does that make sense?
Yes.
At the top where it says or domain F intersection domain G minus, where did that minus sign come from right there?
Oh, from, that's the way.
Oh, is that a minus or a dash right there?
It is a minus.
Oh.
Remember, the domain of a fraction is the intersection of the domains minus, that is, you take away all values that make the denominator function, in this case, the g of x, 0. So yeah, it is a minus. Yes, there is a between sets, even though you're not, you see, you're not subtracting, but you're taking away. In that sense, it's minus.
Homework on this isn't due today, is it?
No, this is chapter 2.
Okay.
Yeah. Okay, so we keep on going along. Okay, so are we ready for a challenging problem, or you want a medium or an easy problem?
Challenging.
Okay, very good. Let's look at 2.1 exercises. They may not be challenging, but 2.1 exercises. So page 61, if you're looking at the book. Let's look at 79. So 71 through 80, the question, okay. 71 through 80. For the given functions, find the following. Find A, F plus G. I'm just gonna write F plus G because we're gonna write it again. B, F minus G, F times G, F over G. Oh no, I need to know, I need to do of X. This is of X. Because now E is F plus G of 3. EF is F minus G of 4. G, if F times G of 2, and H is F over G of 1. Okay, 79, F of X equals 2X plus 3 over 3X minus 2, and G of X is 4X over 3X minus 2. Okay, part A. F plus G of X. Oh, and it also says also find the domains. Blah, 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 and domains. So F plus G of X is the same as F of X plus G of X, right? So the sum is obtained by adding the two functions. So then you just add the two functions. So F of X is 2X plus 3 over 3X minus 2 plus 4X over 3X minus 2. Now in this case, we can take it one step further and simplify. Oh, look, this is a nice problem because the denominators are the same. So then you just add the numerators. Copy 3X minus 2, and then add 2X plus 3 plus 4X. So that gives me 2X plus 4X is 6X plus 3 over 3X minus 2. That's my F plus G of X. And notice that where I can.
Do you not have to simplify the 6X and 3X anymore?
Yes. Okay. So that's what I was mumbling about. How do we simplify that?
Would it not just become 2X?
Remember, you can only simplify a fraction if there are common factors. Oh no, it's not this one. Where is my other rule? I think I did it in red. Or do we did somewhere the cancellation? Okay, let's do it again. Maybe it was the other class. So if you have A times B over A times C, so what's important is the times, and then you have a common factor, then the common factors cancel, so you get B over C. Okay, so that means that I have to factor and see if I get a common factor. So the numerator have a common factor of 3, so I can take out a 3, but the denominator doesn't have any common factors. 3 and 2 don't have anything in common. And one has X, the other one doesn't have an X, so it stays as 3X minus 2. How do we factor the numerator?
Is it
3
2X
times
1?
2X plus 1. Then I look at this, well, this doesn't look like that. And there is no other possible common factor, so that's it. So this is it. Okay. Okay, the domains. What is the domain of f? Here's my f function. So the only thing that has a restriction is the fraction, the division part, right? Cannot divide by 0. Okay, so what is the domain of f? We look at the denominator, 3x minus 2, and you set it to 0. And that is the point we're going to take away from the domain of f. Plus 2 plus 2, 3x equals 2, divided by 3. X cannot be 2/3. And you can check, you put 2/3 for x. So I put a 2/3 here. The 3's cancel, so I get a 2 minus 2 is 0, okay? Domain of G is another fraction. So again, we look at the, oh, it's the same thing. It's the same denominator. The denominator cannot be 0, so the domain of f and the domain of G are the same. So then there is my domain of f. If that is 2/3, everything is shaded except that. What is the intersection?
Everything says 2/3.
Everything says 2/3. Which is equal to x, x is not equal to 2/3. Okay, so therefore the domain of f plus g, which was just the intersection of the domains, is everything except 2/3.
So the domain of f, so you see where you have domain of f and domain of g?
Yeah,
You got both of those from the denominator?
yeah,
So are they
Both
always
of-
gonna be the same pretty much?
because they, only because they have the same denominator.
Oh yeah, I forgot those were the
Yeah.
other ones. Okay,
Yeah, because sometimes they would not have the same denominator, then you have to do the same thing for G.
okay, cool.
Okay, very good. Okay, part B, f minus G. So that would be f of x minus g of x, okay? So f of x was 2x plus 3 over 3x minus 2 minus g of x was 4x over 3x minus 2. So now we simplify. We have two fractions with the same denominator. So just copy the denominator. And then we subtract the numerators. Okay, so the only thing we subtract is 2x minus 4x. So f minus g of x. So that's 2x plus 3 minus 4x. So 2x minus 4x is negative 2x plus 3 over 3x minus 2. And what is the domain of f minus g? Oh, why don't I let you finish this and while I take roll. Okay. So let's continue. What is the domain of f minus g? Is the intersection of the domains, and we already did the intersection, so it's everything except 2/3. Did anybody get that?
Yes.
Okay, very good. Now let's do C. C is probably the product. F times G, and D is the quotient. Of X. So that is F of X times G of X. And then you just copy F of X and multiply with G of X. 2x plus 3 over 3x minus 2 times 4x over 3x minus 2. So then we're multiplying 4x times 2x plus 3 in the numerator, and the denominator is 3x minus 2 times itself, so we can do it square. Okay, so now there are no cancellations, so you can leave it here, or you can take it one step further and multiply it out. 8x squared plus 12x over 3x minus 2 squared, or if you want to multiply out 3x minus 2 squared, that's fine too. Domain of the product is the intersection of the domains, which we already did. So it's all the x's, so that x is not equal to 2/3. Okay, D, the quotient. Okay, are we following?
Yes.
Okay, so f of x over g of x. Now, because f and g are themselves fractions, you could, one way to avoid a complex fraction is by looking at f of x over g of x as f of x divided by g of x, right? So then you get 2x plus 3 over 3x minus 2 divided by 4x over 3x minus 2. I mean, you can do it as a fraction also, but you get a complex fraction, and you might like this one better. Now, how do we divide fractions? So the rule says if I have A over B divided by C over D, that the division becomes a multiplication of the first fraction and the reciprocal of the second fraction. So the second fraction flips. So we do that. So we get this equals, the first fraction stays put, 2x plus 3 over 3x minus 2. The second fraction, you flip it. So it's 3x minus 2 over 4x. Now notice that the numerator, if you put parentheses between numerators and denominators, that we have this product, and now we have a common factor of 3x minus 2 that we can cancel. So f over g of x is therefore 2x plus 3 over 4x. Any questions? Okay, you can still hear me, right?
Yes.
Yes.
Okay,
Yes.
good. Okay, domain. Domain of f over g is the domain of f, intersection domain of g. Take away all the x's so that g of x is 0. Okay, so we already know the intersection. So the intersection of f, domain of f and domain of g is all the x's so that x is not equal to 2 over 3. Now we take away the elements of the set. The seconds of that set where g of x is 0. So I look at g of x, and what was g of x? So notice that g of x was 4x over 3x minus 2. So we want to find out where this is 0. So we set that into an equation. So we multiply both sides by 3x minus 2. So then I get 4x over 3x minus 2 times 3x minus 2 equals 0 times 3x minus 2. So notice that the fraction disappears on the left, and that was the whole purpose of multiplying by 3x minus 2. So I get 4x equals 0 times anything is 0. 4x equals 0. Divide by 4. So x equals 0 divided by 4. What is 0 divided by 4?
0.
Zero.
0. Yes. No, it's 0. Now, 0 divided by 4 is 0 because when you multiply 4 times 0, you get 0.
I have one question,
It
Miss.
is. Yes.
So you know how we multiplied both sides by 3x minus 2?
Yes.
So wouldn't that instantly get rid of the bottom fraction of 3x minus 2 and then keep the one that we just multiplied?
Yeah, that's how we got the 4x.
No, I mean like the bottom fraction would disappear, but then the one that's on the 0 side would stay, no?
But then you still have to multiply by 0. Right? What is 0 times
Oh.
3x minus 2?
Oh yeah, I see.
Yeah, that's right. Okay, very good. So we take away 0. So we go back to this expression. So it's the set of all x's, so that x is not equal to 2/3. Take away 0. So now we combine these two conditions. So then let's continue here. So therefore the domain of f over g is the set of all x's, so that x is not equal to 2/3 and x is not equal to 0. There's your domain. Any questions? Okay, I think you might be able to do the homework for 2.2. It's a very short section. So I'm just going to give you, let's see if you can handle this. So 2.2. So we're just looking at some the graphs of functions. Okay, so I'll give you the technical definition on Tuesday. Well, so you've asked for the domain, for the range, for the intercepts. Oh, we're not doing the increase and decrease in here. Okay, so see if you can do the homework for 2.2 also. So some of them are we already talked about. So so the theorem, the vertical line test. So this is the vertical line test for functions. So given the graph of a relation, this is a function if and only if every vertical line intersects the graph at most one point. So then, so if you have the graph of a function that looks like that, say, versus one that goes, say, vertical. So then the first one is a function, because if you look at a vertical line, if you move it around, then it intersects the graph at only one point. But if you look at the second example, this here there is no intersection, but then it starts intersecting at 2, 1, 2, 3 points, 3 points, 2 points, or 1 point. So that is not a function because it intersects at more than one point. So this is a function. This is not a function. So you probably remember this from your algebra class. Now, some things that you will need to know about functions is that intercepts. The x-intercept.
Professor, does the class end at 12:45 or 1 today?
Oh, it's 12:45. I was thinking 12:50. The class ends at 12:45.
Okay, I just want to make sure
Okay.
because I have another.
Yes.
Yeah.
Yeah, go ahead if you have to leave. I'm just gonna give a couple guidelines so you can do homework for 2.2, which is short.
Is this gonna be on my math lab or is this gonna be on the textbook or both?
Both.
Okay.
Okay.
But not due today, right?
No, it's not due today.
Okay.
But I want to take advantage of the long weekend.
Okay, cool.
And you'll see it's short. There are only like 6 problems.
But we're
So,
gonna leave if we have another class.
Yeah, you can go and then you can come back and finish watching it.
Okay, thank you. Have a good day.
Yeah. Sorry about this.
No worries.
But yeah, if you'll do your best, and if you still cannot do it, then we'll go over that on Tuesday.
Okay, thank you.
So you're welcome. It x-intercepts when the graph crosses the x-axis. That means the y value is 0. Y-intercept or y-intercept when the graph crosses the y-axis. That is x equals 0. That's what they're gonna show you. Positive and negative. If you have a function greater than 0, so that will be when the graph is above the x-axis. And for x less than 0, when the graph is below the x-axis. I think that's all you need to know. And then they're giving a graph, and then you have to answer those questions. Okay, so do the homework for 2.2 also. Any questions? I can
Can you scroll up really quickly. I just wanted to make sure I'm clear. So it's not a function on the right because it only touches the y-axis once. Is that right?
no, it crosses a vertical line. We're looking at the vertical line intersecting or crossing the graph at most than 1 point. So this is the x and that's the y-axis. And the blue line is a vertical line. Okay, so if you find one vertical line that crosses the graph at 3 points, 1, 2, 3, then it automatically is not a function. But on the example on the left, you cannot find a line that crosses the graph at more than 1 point. When I'm looking at the graph, I'm looking at this picture, right?
Yep.
That's the graph. Okay.
Yeah.
So there is no, so if you take the vertical line and move it around, there's only 1 point of intersection. So this is a function.
Yeah, I remember these. Thank you.
Okay, yeah, very good.
I have a question about the homework that's due tonight. I have, there's 2 problems that are similar. It's from 1.1, if you don't mind.
No, not at all. Okay, 1.1.
Yeah, so problem 12 and 13, they're similar problems, and I'm getting stuck doing both of them. If you could just show me one of them all the way through. I looked at the example on MyMathLab, and I'm still having issues.
Okay, so read me the problem, number 12.
So number 12 is plot each point and form the triangle ABC and then find the area. And so point A.
Oh, okay, so that's the one I was doing before class. Benjamin came to see me. Okay, so what are the points?
So point A is -112. Point B is 6, 7, both positive. And point C is 1, 0.
Okay, so it's different from yours, Benjamin, but it's the same idea. So you want to check if it's a right triangle, right?
Yes.
Okay, so to check if it's a right triangle, then you have to see if you have the situation a squared plus b squared equals c squared. Okay, so then A, B, and C are going to be the size of the triangle. So then you look at the distance from A to B, that would be one side. From B to C would be another side, and H to C would be another side. So to find the distance from A to B, so you're going to use the distance formula and find the distance from A to B. So I guess we're doing blue now. So it's the square root of what?
So it's x squared minus x1. Do you want me to fill it in or just, I could fill
Okay,
it in.
fill it in. Maybe
Yeah,
x
so
of 2 minus.
x of 1 squared plus y sub 2 minus y sub 1 squared.
Okay, now substituting the values.
So it'll be 6 minus -1 squared plus 7 minus 12 squared.
Okay, simplify that.
I got 7 squared plus -5 squared.
Okay, and that gives you?
I got 49 plus 25.
Okay.
And then 70 square root of 74.
74. Okay, BC.
BC is 1 minus 6 squared plus 0 minus 7 squared.
Okay.
And then simplified is -5 squared plus -7 squared.
Okay.
And then simplified is 25 plus 49.
Okay.
And I got the same answer, square root of 74.
Okay.
And then
One more.
AC, I got 1 minus -1 squared plus 0 minus 12 squared,
Okay,
simplified 2 squared plus -12 squared,
okay,
4 plus 144,
okay,
and simplified square root of 148.
okay. So now we have to pick what's A, what's B, and what's C. Okay, so the only requirement is C must be the largest. Okay, so then that means that C must be,
Square root of 148.
okay. And then A and B, in this case, they're the same, but A and B can be interchanged. 74. Okay, so now check if we have A squared plus B squared equals C squared.
Oh, I didn't do the check. Okay.
Okay,
A squared plus B squared. So it should be square root of 74 plus square root 74 equals
Where?
square root of 148.
right. And each one is square.
Each one is squared, right? Hang on, let me get my calculator. So
So 74 plus,
74.
is that equal to 148?
Yes, it is.
Yes.
So is that checks out then, right?
So it's a right triangle.
Okay.
Now, in a right triangle, so this is not the correct orientation, but basically we have a right triangle. So if the legs are A and B, then that means that the area is 1/2 AB. Right? Because if one leg is the base, then the other leg must be the altitude.
Mhm.
Okay. So in this case, A is,
Area equals half of 74 times 74, right? Am I multiplying?
square root. Don't forget the square root.
Square root. Okay.
Square root of 74 times the square root of 74. What is that equal to?
74.
What is it?
74.
74 over
2.
2. Because the square root of 74 times square root of 74, that's the same thing as square root of 74 square. Right? Because this is the same as square root of 74 square over 2. And the square and the square root, they are opposite of operations. So you're left with 74 over 2.
And do we
So then, yes,
we do? So would it just be 37 or do we keep it
Yeah.
as a fraction? Okay.
no, whenever you can simplify the fraction, you simplify.
Okay.
So 37 square units, whatever the units are.
Square unit. Okay.
Okay.
Thank you.
So I had a couple of questions for my homework as well.
Okay. So we'll go around. Okay. So Bashir is next. What's your question?
So mine was number 55 on the 1.1. It's geometry. The medians of a triangle are the line segments from each vertex to the midpoint
Yeah.
of the opposite side. So
Okay.
it shows us the figure, and then find the lengths of the medians of the triangle with vertices at A equals 2, 0, B equals 8, 0, and
Okay.
C
Hold on a
equals,
second. What do you say?
oh, A is 2, 0,
2, 0. B is
8, 0,
8, 0. And C is
4, 6.
4, 6. Okay. So here we have a triangle. Now here we'll graph it, I guess. So 2, 0. That's A. 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. That's B, and this is 4, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So this is a triangle, basically. And it says to find
To find the
the
medians.
length of the medians, right?
Yeah, so to find the lengths of the medians, yeah.
Okay, so a median connects a vertex to the midpoint of the side opposite. So first I have to find the midpoint. Say I want the midpoint of BC, right? Let's call it M1 for midpoint 1 because we're going to have 3 midpoints. What are the coordinates of M1? So it has to do with the
Can you repeat that? Sorry.
say it again.
Can you repeat what you just said?
The sum and then divide by 2. The average, 4 plus 8 over 2, 6 plus 3 over 2, right? What is that equal to?
4 plus 8 over 2 would be 6, and then 6 plus 3 over 2 would be 4.5, but we could just write it as 9 over 2.
Yes, 9 over 2. Okay. So if I connect that with point A, that's 1 median. So now we find MA. So we just use the distance formula. So here are the points, and then apply to the distance formula. Like 6 minus 2 square plus 9 over 2 minus 0 square. Right? So that's 4 square plus 9 over 2 square. And then we keep on simplifying. 16 plus 81 over 4. And then we have to do the LCD. Multiply by 4. So then we get, we'll make it longer. So it's 4 times 6 is 24, carry 2. 4 times 1 plus 2 is 6. So it's 64 plus 81 over 4. And that's 145. Is that right? 145, but the square root of 4 is 2. So it's 140, square root of 145 over 2. Then we try to simplify. That's 5 going to 145. 5 times 2 is 10. 5 times 9 is 45. So it's 5 times 29. So that's it. MA is square root of 145 over 2. So, and then you keep on going. Then you look at the midpoint of A and B, say.
Yeah, the midpoint of A and B would be 4 plus, so it'd be 4 plus 2 divided by 8.
So for A and B, you're only looking at the corners for A and B. The 2, 0 and the 8, 0, right? So you're looking at the average. So the X components are 2 and 8. So 2 plus 8 divided by 2. The Y components are 0, 0, 0 plus 0 over 2. Does that make sense? So what is that equal to?
That equals 5 and 0.
5 and 0. Now we connect M2 with C and find that median, M2C. And apply the distance formula and keep on going. Do you think you can continue this?
Yeah.
Okay, so continue while I answer another question, and then if you get stuck, you can let me know. Okay, who has a question? Benjamin, do you have a question?
I have a question actually.
Which one?
For number 49 in the 1.4.
1.449. This
in the
is
11th position.
1.4. You said 49, right? 49 from the textbook or from must be from the textbook, huh?
Textbook, yeah.
49. The equation of the line containing the centers.
Yeah, the wording, I guess, just kind of confused me.
Okay. Find an equation of the line containing the centers of the circles. Okay, so we have x minus 4 squared plus y plus 2 squared equals 25. X plus 1 squared plus y minus 5 squared equals 16. Okay, so first you can see that we have two circles, right? One circle and another circle. Now let's do the graph so that we can visualize and see what's going on. What is the center of the first circle?
It's gonna be 4 and -2.
What is the radius?
5.
5. Very good. What's the center of the second circle?
-1 and 5.
And the radius?
4.
4. Okay. So here we have x and y axis. Okay, so 4, -2. That's one center, and then it has radius 5. 2, 3, 4, 5. Okay, so we get a circle, something like this, roughly. Okay, so that's the first circle. The second circle has radius -1, 5. And radius 4. 1, 2, 3, 4. So we get okay, so we got this. So we have two circles. The other center is -1, 5. But now it's saying find the equation of the line that contains the centers of the circles. So you're just looking at the centers. So here's one center, here's another center, and the line that goes through those two. Okay, so once you identify that, you don't even need the circle. So you're just looking at that line. Does that make sense?
Yeah, it does.
Okay, so basically find the equation of the line passing through. So notice we didn't even need the radius, just needed -1, 5 and 4, -2. Do you know what to do next?
I was hoping that you'd go through all of it.
Yeah, go
Please.
ahead. Let's go ahead. So we have a we want to find the equation of a line given 2 points. So in that situation, the first step is to find the slope. So m equals y2 minus y1 over x2 minus x1, change in y over change in x. Okay, so let's find the slope. So we can call this x1, y1, x2, y2, and then we plug in. And so we do a y2, -2 minus 5, x2 minus x1, 4 minus -1. And so what do we get here? -7, is that right?
Yeah, and 5.
Over 5. Okay, so the first step is to find the slope. The second, you apply the point slope form. Now, by the way, we're going to come back to this on chapters 3, I believe. I think 3.1 is lines. Yeah, so we're going to come back to this. We're going to practice more again. The Pointers-law form is y minus y1 equals m x minus x1. So I could use this x1, y1, and m, okay? So just plug in. Y minus 5 equals negative 7/5, x minus negative 1. Okay, and then after that, just simplify it. Y minus 5, distribute the negative 7/5 by x minus negative 1 becomes x plus 1. So you get negative 7/5 x minus 7/5. Is that correct?
Yeah.
Okay, then we can add a 5 on both sides. So y equals negative 7/5 x. And then on the side, we can do negative 7/5 plus 5. We need the LCD. So multiply by 5, top and bottom. So I get negative 7 plus 25 over 5. And that gives us, what is that? 18 over 5, is that right? So there's the equation of the line.
Okay, thank you.
You're welcome. Okay, next. Somebody who hasn't asked yet. David or Benjamin? Okay, or Bashir?
Yes. Hello?
Do you have a question? Yeah.
Yeah, so I'm fine with the one that we just did, but I have a question on a different one.
With number what?
On number 11 on 1.4, I think. Give me one second.
1.411.
Yeah, 1 second, let me just check. Yeah, so my question was, it's asking for me to find the center of the circle and the radius, but so I have the 2 points from the outside of the circle, but I don't know how to find the center. Do I just try and find the midpoint? Is that how I get it, or?
Yes, provided that the 2 points make a diameter.
Pretty sure
So imagine you connect the 2 points with a line. Does that line go through the center?
Yes.
Then yes, the midpoint is. So if this is the center, and then if you get these 2 points, and if that is the case, then the center is the midpoint.
All right. Okay. I just had to make sure for that one.
Yes.
And then, so this one is a vocab one. I just couldn't find the answer for it. It's to complete the square of x squared plus 10x, you would add or subtract, I'm not sure which one it is, the number.
Yes. So remember when we were doing these the circles, and there's one part in which we have to complete the squares so that we can factor and get something to form x minus a number square.
I think so.
Okay, so that's what they want you to do here. So we wanna to complete the squares. So you take the coefficient of the x term, you take half of it. So half of 10 in this case will be
5.
5, and then you square that.
So it'd be adding 25.
Yes, 25.
Oh,
So you
okay.
add a 25, and that's because you see if you factor x squared plus 10x plus 25,
Mhm.
then you should get 2 factors that are the same.
Oh,
Okay, so remember how to factor this?
it would be x plus 5, and then x plus 5 on the row.
Right. And if you multiply, you should get x squared plus 10x plus 25. So that is the idea. The purpose is to get into 2 factors that are the same. That is a perfect square.
I see. And then I had another question. It's for number 25.
Okay, just 1 minute. Benjamin, did you have a question to give him a chance also? Benjamin, are you there?
Yeah.
Okay, did you have a question?
Okay, for number, is it possible for number 12 to not be a right triangle?
Okay, so let me go to Benjamin and then come back to you, Bashir, okay?
All right.
Okay, Benjamin, what was your question?
Basically, I tried to do number 12, but the number, like the numbers were equal to each other, so can it not be a right triangle?
Number 12 in 1.4.
1.1.
Okay, did you want to show, okay, why don't you show, do you have your screen?
Yeah.
The problem, okay, why don't you share, okay? So hold on a second, let me, I don't want to share this. Okay, here. Okay. Okay, so show me your screen. Oh, you're showing me the other. Okay, that's another. Okay, hold on a second. I have to make it bigger. Okay, so that's the one that we're working before.
Yeah.
Okay, so square root, you got a square root of 65. And the other one is square root of, is that 146?
Yeah, it's 146.
Okay, 17. Yeah, there's something wrong there. Okay, we have to do it. Let me go back to notability. Okay. So you're gonna give me the numbers again.
So it was a negative
So what-
4. What?
-4,
11.
11, B,
3, 7.
C.
-1 and 0.
Okay, is it the same as, it's not the same, right? 4, 11, it doesn't look the same. Yeah, it's not the same. Okay, so this is the one where we have to show if it's a right triangle. So since you already did it, let me do it quickly and then you compare with what you have. So AB should be 3 minus -4 plus 7 minus 11. So that's 7 square plus 4 square, -4 square, right? So it's 49 plus 16, 65. So did you get the square root of 65?
Yeah.
Okay, and BC, it should be 3 minus -1 square plus 7 minus 0 square. So this is also 4 square plus 7 square, so it's 65. And AC is -4 minus -1 plus 11 minus 0. So that's -4 plus 1, so that's a -3 square. So that's 9 plus 11 square, 121. Okay, I think your 121, 11 times 11 is 11 and 11, so it's 121. And then you add a 9, so you get a 130. Is that correct?
Yeah, mine got 146.
Okay, so that's where you went wrong. Okay, so now check that a squared plus b squared equals c squared. So square root of 65 squared plus square root of 65 squared, is that equal to square root of 130 squared?
Probably.
Okay, let's check quickly. Now, in this class, you are allowed to use a scientific calculator.
Not graphing calculator, right?
But this one you can do by hand.
A professor is graphing calculator allowed?
No, just scientific calculator.
Okay, well, I don't have one anyways.
You don't have one?
Oh, I mean, I don't have a graphing calculator anyways.
Oh, good. So you won't be tempted. No, just a scientific calculator. Did you get 130 equals 130?
Yeah.
Okay, very good. So it's a right triangle, right? So that's the condition for right triangle. So now we find the area. Isn't that right?
Right.
Okay, so then if you want to graph, okay, so let me do it again. So if we want to graph the triangle, so we have x and y, negative 4, 11. Let me just estimate and say this is point A, negative 4, 11, 3, 7. So this is B, 3, 7, and negative 1, 0. And that's a C. So we have roughly this picture. It's not accurate, but just to give a little visual. AB is square root of 65. BC is square root of 65. And AC is square root of 130, right? Since C is the largest and it's a right triangle, so then this should be a right angle. So then those are the A's and the B's. So in a right triangle, or in general, the area is 1/2 base times height, but in the right triangle is 1/2 the product of the legs. So just use A square root of 65, B square root of 65 to find the area. Okay, so what is the area?
Half of 65.
Is square root of 65 times square root of 65? Yes, which is half of 65. Or 65 over 2 square units. Yes. Oh, I got disconnected. Okay, so let's try again. Okay. Okay, so let me go back to Bashir and then I'll come back to you, Benjamin. Bashir, what's your next question?
My next one was the number 25. So it is find the center of HK and radius R of each circle, and then we have to graph it and find the intercept.
Okay, and what is the equation?
The equation is 2 parentheses x minus 3 parentheses square root, or not square root, sorry, square, plus 2y squared equals 8.
Equals 8.
Mhm.
Okay, so that's 27 in the textbook. Okay, so find the center. So now this one doesn't have the right format, okay? Because you want to compare to x minus 8 squared plus y minus k squared equals r squared. There is nothing in front of the parentheses, or here we have the 2's. Okay, so what do?
We try and get those standard form.
Get rid of the 2's. How can we get rid of the 2's?
Divide both sides by 2.
That's right. Or divide each single term by 2. So then we get x minus 3 squared plus y squared equals 4. What's the center now?
Sorry, can you say that again?
What is the center of the circle?
The center would be -3, 0. Yeah, -3 and 0.
3.
Oh, no. Yeah, 3 and 0. Sorry.
3, 0. And what's the radius?
The radius is 2.
2. Very good. So then it says graph. Graph the circle. Three, 0. With radius 2. There you go. Graph the circle radius 2, find intercepts, if any. So x intercepts, you said y equals 0, right? So you can go to this expression and set y equals 0. X minus 3 squared plus 0 equals 4. Or x minus 3 squared equals 4, right? Keep on going.
So it would be x minus 3, 4 square root, or well, be 2.
Plus or minus.
Yeah, plus or minus 2, and then you'd subtract 3 from both sides, or add 3 to both sides, and then it'd be plus or minus 2.
Very good. And 3 plus or minus 2 gives you?
It's either 5 or -1.
Very good. There's your 5. And then a positive 1. 3 minus 2.
Oh, it is.
Yeah. Okay, any y-intercept? You can see that it's none. So let's see what happens if we try to calculate it. So we get a 0 minus 3 is -3 squared plus y squared equals 4. Or 9 plus y squared equals 4. But when you try to isolate the y squared, you subtract a 9 on both sides. So you get y squared equals -5. Or y equals plus or minus square root of -5. Not real. So no y-intercept. Okay.
And so do I have to, because some of them are like this, do I have to show work if they don't have y-intercepts?
So you can see, yeah, this is how you show work. Okay, back to you, Benjamin, and then I'll come back to you, Bashir, if you have another question.
All right.
Okay, Benjamin.
Okay, I think I might need help with help on number 18.
18, okay, so you have to tell me what the problem is.
Find all points having an x coordinate of 4 whose distance from the point -4, 2 is 10.
That is 1.1, right?
Yep.
Okay. So final points with x coordinates is 4, so it's 4 something, and the distance to what point?
-4 and 2.
And the distance is
10.
8.
10.
Okay.
It's
So
10.
oh, 10, I'm sorry. I don't know where I got the A from. So let's call this P and this Q. Okay, so we're saying that the distance from P to Q is 10. We apply the distance formula. Now, I don't know the second component of P, so let's call it Y. And so you apply the distance formula to 4y and -4, 2. So that's the square root of what?
4.
4 minus
-4.
-4 squared plus y minus
2.
2 squared equals 10. Okay, so now what you have here is you have an equation where the variable is y. So you want to solve for y. Because the y appears in only one place, then pretty much we want to isolate the y. So first get rid of the square root. Square both sides. And at the same time, we want to simplify 4 minus negative 4. What is 4 minus negative 4 squared?
8.
8 squared. And then keep the y minus 2 squared as y minus 2 squared equals 100. And 8 squared is 64 plus y minus 2 squared is 100. And then we keep isolating the variable. So what is the next step? Subtract 64 on both sides. And you get y minus 2 squared equals.
Beginning part.
Say it again.
I'm still writing down the beginning part.
Oh, you're still writing down. Yeah.
Okay.
Okay, so y minus 2 squared equals
36.
36. What's the next step?
Square root again.
Square root. So then we get plus or minus square root of 36. So y minus 2 must be equal to plus or minus
36.
square root of 36, which is
6.
6. Okay, solve for y. Add a 2 on both sides. So y equals 2 plus or minus 6. Is that correct?
Correct.
So y equals 2 plus 6, or y equals 2 minus 6. So that takes you to y equals 8 or
-4.
negative 4. Very good. And you can take a you can graph and see what's going on. So let's see. So -4, 2. So this is -4, 2. So then 4, 8. That would be 4, 8. And 4, -4. So those are the 2 points that are 10 units from -4, 2. Okay, Bashir, your turn.
Okay, so my next question is a similar one to the one I just did. So it's number 36 in the other book that you provided us, and
36
it's
in 1.4.
yeah, 36, but it's in the 10th edition.
Oh, it's the 10th edition. Okay, so you have to tell me what the problem is.
So it's 2x squared plus 8x plus 2y squared equals 0.
Okay. So this is 1.4 still. So find the center, find the radius, graph, and find the intercepts. Is that correct?
Yes.
Okay. So the coefficients of x squared and y squared are both 2. So we have to get rid of that. So what do?
So we multiply both, or we divide both sides by 2.
Yes. Every single, or divide every single term by 2. So we get x squared plus 4x, leave a space to complete the squares, plus y squared equals 0. Now complete the squares. Do you remember how to complete the squares?
Yeah, so it would be half of 4, so it'd be 2
And 2 squared is,
4.
so you add a
Add
4
4
on
to
both
both
sides.
sides.
Okay. Now factor the first trinomial.
It'd be x plus 2 squared.
Plus y squared equals 4.
Mhm. And
What's the center?
the center is -2, 0.
What's the radius?
The radius is 2.
Okay, so graph the circle. So you get something like this.
Yeah.
So that's part A, part B is graph. Okay, part C, intercepts. X-intercept. Said y equals 0. So we go back to here and we said y equals 0. So I get x plus 2 squared plus 0 equals 4. Solve for x.
So solve for x would be, y would become 0. So it'd be x plus 2 is 2.
X plus 2 plus or minus 2.
And then
So-
it'd be, and then we subtract it from both sides. So we would have x equals 0 over 4.
So 0 or
4.
negative 4?
Wait, yes, negative. Yeah, negative.
Okay. And that is your 0 here and your negative 4. Y-intercept.
So the y-intercept would be 2 squared
2 squared
plus y squared plus 4 would be, yep. And then we
y
would,
squared equals,
0,
so y equals,
0.
very good. So this one takes you to 0, 0, negative 4, 0, or this takes you to 0, 0. Very good.
And then does Benjamin have another question?
What was that?
Does Benjamin have another question, or can I ask
Okay.
another?
Okay,
Hey.
let's see. Benjamin?
You can do another.
Okay.
I'm
Just
doing.
Yeah.
So my next one would be 37. So 37 is this 37. So it's the find the standard form of the equation of each circle. And we get the center is 1, 0, and the containing point is -3, 2. So my question was, is the containing point the point on the circle?
Yeah.
Oh, okay.
So
So-
this is 1.4. So the center is 1, 0, and it passes through that point.
Okay, so I think I can do this one if it's that way.
You can do that?
Yeah, so I just didn't understand the question for this one.
Yeah. So if this is the center, so if this is the center 1, 0, then -3, 2. Actually, let's make it smaller. -3, 2. 1, 2, 3. 2, 3, 2. So then the circle will have to look like something like this.
And then we can find that by doing the equation, right? The x plus h, and what's it called? And we can find,
The standard form.
yeah.
Yeah. So so basically you have the center, you have to find the radius. Right? That's the only thing you need, and then you can plug it into the standard form.
Mhm.
What is the radius?
So it would be
From the center to a point on the circle, that's the radius.
mhm,
So basically, you just find the distance between these 2 points. Use the distance formula and find the distance, and that would be the radius.
distance formula is, what's it called? -3 minus 1, or is it the plus 1?
Either way, so you can call this x1 and this x2, or vice versa. But
Okay.
if you go like that, you get -3 minus 1 squared plus
2 minus 0.
2 minus 0 squared under the square root. And then we simplify, so this will be the radius.
So it would be 4 squared, -4 squared, and then 2 squared. And then that would be 16 plus 4,
Mm-hmm.
and then it'd be 18 squared.
20.
Oh, no, yeah, 20, sorry.
Okay. And then we simplify the square root of 20.
And that would be 2, and then 2 would be outside, and then 5 would be inside.
Yes. Because 20 is 4 times 5, and 4 is a perfect square. So that's your radius. So now you go to the standard form, x minus h squared plus y minus k squared equals r squared, and you plug in. So what do you get?
So it would be x minus 1
X minus 1 squared plus
plus y minus 0.
y minus 0 squared equals
2 square root of 5 squared.
Okay, so now just simplify it. So you get x minus 1 squared plus
Plus y squared.
equals
It's before plus 5
times.
times 4 plus 5. Wait, no. Wait, how would we do this one?
So it's 4 times 5.
Oh, it'd be 4 times 5. Okay. And that would be 20.
That's right. Which is also, if you use the square root of 20, they're going to fit 20 there. So it's, okay, it's consistent.
Mhm.
So there's your standard form.
I see.
Okay, Benjamin, do you have a question?
Yeah, I have one for number 20 on 1.1.
120. Okay, so tell me what the question says.
The medians of a triangle are the line segments vertex to the midpoint of the opposite side. See the figure. Find the lengths of the medians of the triangle with verses at A01, B81, and C23.
B was A1.
And
Did I
C2.
copy correctly?
Yeah.
Do I have the points correctly?
Yes.
Benjamin?
Yeah.
Okay. All right. So then we have a triangle with vertices A, B, and C. And then if we want to have a guide, so basically we have 0, 1 is A. B is A1, 1, 2, 3, 8, 8, 1. That's a B. and C is 2, 3. So this is a triangle question. Okay, so the median connects a vertex to the midpoint of the side opposite. Okay, so for example, if I look at the midpoint of AB, so this is, let's call it M1. So then when you connect C with M, you get a median, right? Okay, so to find the midpoint, so the midpoint of 2 points will be the average, right, of the X components and the average of the Y components. Okay, so what is M1? So I'm looking at this line segment and the endpoints are 0, 1, and 8, 1. So what is the, how do I find the midpoint?
You put in M0 plus 0 plus 8.
0 plus 8 over
2.
2. And the Y?
1 plus 1 over 2.
Very good. So we get 0 plus 8 over 2, 1 plus 1 over 2. We simplify, and what do we get?
2 over 2, 1.
8 over 2?
4.
4, and 2 over 2 is 1. 4, 1. C was 2, 3. So then CM1, so that will be the length of this line segment. So now we apply the distance formula to those 2 points, 2, 3, and 4, 1. Okay, so the distance formula again. So CM1 is the square root of what?
One minus 2.
Square plus, wait, 1 minus 2. 1 is Y and 2 is X.
1 minus 3.
1 minus 3, yes. 1 minus 3 square plus
4 minus 2.
very good, square. Okay, simplify. One minus 3 square will give you
4.
negative 2 square, which is 4, and 4 minus 2 square,
It's also 4.
also 4. So that's the square root of 8. Can we simplify the square root of 8? What times what gives you 8?
4 times 2.
And that's a good one because 4 is a perfect square. So square root of 4 times 2 therefore becomes
2, 2.
2 is square root of 2, right? Because the only perfect square is the 4. The other one is not a perfect square, so it stays as square root of 2. Okay, M2. So now we're applying the midpoint formula to C and B. Okay, so find the midpoint of find M2, the midpoint of C and B.
Is it 1, 1,2?
1,2. Not the 1. The 2 is correct because 3 plus 1 over 2. 3 plus 1 over 2 will give you 2. But the other one is 2 plus 8. And that will give you
5.
5. Okay, distance formula applied to, we connect A with M2. So distance formula applied to A and M2. Did you get something like 5 minus 0 square plus 2 minus 1 square? Right, because we're doing 5 minus 0 and then 2 minus 1. Okay, so tell me when you're done simplifying.
I got the square root of 26.
Very good. Okay, one more, M3. So now we're looking at the midpoint of AC. So we're looking at A and C, find the midpoint. So it's the average of the X components and the average of the Y components.
I got 3.5 and 2.5.
What did you get 3.5? Walk me through.
2 plus 5 divided by 2 plus 3 plus 2.
No, we're not looking at the midpoint between C and M2. We're looking at the midpoint of AC. You see this other side. So you're looking at the corner 0, 1, and 2, 3. Okay, so try again.
All right, is it 1, 1, 2?
Yes, very good. 1, 2. You know, there are a lot of expressions involved. Okay, so 1, 2. So now that's M3. So now we connect M3 with B. So B, M3. Okay, so let's highlight the points involved, M3 and B. So we're looking at this length. Okay, so how do you find that length? Distance formula again. So apply the distance formula, simplify, and what do you get?
Square root of 50.
And simplify the square root of 50. What times what equals 50?
10 times 5.
Now 10 is not a perfect square, 5 is not a perfect square. So try another breakdown. So 50 is 10 times 5. In fact, what you can keep on doing is factor. So 10 equals
5 times 2.
5 times 2. So whenever you have two prime factors that are the same, that gives you a perfect square. So it's 2 times 5 times 5, or 2 times 25. So 25 is a perfect square. So BM3 will be
5 in the square root of 2.
yes, 5 square root of 2. There you go. So you found the length of each of the medians. Okay, back to you, Bashir.
All right. So my next one is a question about the way it's worded. So it says
About the what?
So my
I'm sorry.
question is about how it's worded, because if it's what I think it is, I can do it, but if it's not, I'll need help.
Okay.
So it says it's still 1.4. So it says with endpoints of a diameter at 4, 4, and 3, and 0 and 1.
Yeah.
So I have to find the standard form for that.
Yeah. So to find the standard form of a circle, what do you need?
I need this. I need the center and the radius.
That's right. Can you find the center?
If I think what it is, I think it's two sides on the circle, and if I find the midpoint, I think that's what the circle would be.
Right. As long as these 2 points are, if you connect these 2 points with a line, and if it contains the center, yes, the center will be the midpoint.
All right. So all right, then I can do this one.
Okay.
So my next one it's called Ferris wheel. So
Yeah.
it's a Ferris wheel has a maximum height of 270 feet and a wheel diameter of 260 feet. Find an equation for the wheel if the center of the wheel is on the y-axis and y represents the height above the ground.
Okay, so we have the y-axis and the height of the Ferris wheel is 270, you say, right?
Yes.
And but the diameter is 250.
Not 260.
260.
Mhm.
So then that means that the difference between 270 and 260 is 10. So then that means that the lowest point of the Ferris wheel is 10 feet above the ground. Okay?
Oh, that's all I needed to do?
No, you want to find the equation of the circle, basically, right?
Well, it says the Ferris wheel has a maximum height of find an equation for the wheel
And
of the
the-
center. Yeah.
Yeah. if the center is on the y-axis. So if this is the center, and this is the x, this is the y-axis. So from here to here is 270. From here to here is 260 feet. Then this is 10. So let's call this 10 feet. So to find the equation of the circle, you need the center and the radius. Where is the center?
It's in the middle,
Sorry.
so it's in the middle, so it would be 130. Oh no, not 130.
0, comma.
it'd
So
be-
the points are, you see, if you can think of this point as 0, 10, and this
Yeah.
point as 0, 0 what?
270 or 260.
270.
Yes, so
Okay. So then you want, the center is the midpoint of 0 to 70 and 0, 10.
oh,
So what is the midpoint?
so the midpoint would be 0 plus 0 divided by 2. 10 plus 270 divided by 2.
Okay, so that gives you,
That gives me 0. 280 divided by 2 is 140.
140?
Yes.
Okay, so that's the radius. I mean, that's the center. What's the radius?
The radius would be 0 or 0 minus 0
Square
square
root of, okay, 0 minus 0, the distance formula.
plus 140 or yeah 140 minus 270.
Minus
Or wait,
270.
Yeah.
Either
because-
way,
And then that would be, so it would go down to be square root of nothing, because 0 squared is nothing. And then 140 minus 270 would be negative 130. And then when we square that, it would give us, let me check.
but you're squaring and then you're taking the square root.
Yes. Oh,
So it's
so
just-
it'd just be 130.
That's right. So the radius, so you got everything, the center and the radius,
Oh, okay.
and
So-
find the equation.
The equation would be 0 minus 0 or
X minus
0 squared plus y minus 140 squared, that equals 130
Square,
squared.
and then just simplify it.
And then to simplify that, what we would need, we just do that, and then y squared. Or
I think the one is standard form.
oh,
Oh, it doesn't
is it?
say, but just
Yeah,
leave
it
it
doesn't
standard
say.
form.
And then do we have to do the square root of 130 or no?
Yeah, if you are doing this, yeah,
So it'd be 16,900.
60,000.
900.
Are you sure? Because 13 times 13 is 9. Oh, my wrong. 3, 13, 169. And then there are 0, 0, so there are 0, 16. Oh, that's what you said, right? 16,900. Okay, thank you. Okay, Benjamin.
I think I'm fine.
Okay, very good. Bashir?
Yes, so my next one would be, 1 second, let me check. So 51, that 58 would be, so it says find an equation of the line containing the centers of the two circles. And then the equation for the two circles is x squared plus y squared
X squared plus y squared
minus 4x plus 6y plus 4 equals 0.
and the other circle.
And the other one is x squared plus y squared plus 6 plus 4y.
Plus 6x or 6
Yes, 6x, sorry.
plus 4y?
Plus 9 equals 0.
Okay. So, so basically you have these two circles, right? And I don't know how they are oriented or how they're placed in the plane, but each one has its center, right? So then the question is, what is the equation of that line? So the circles are not relevant, really, just the centers. So you're looking center 1, center 2. So the only thing you have to do is find the center of each circle. So how do you find the center of a circle?
By changing the general form to standard form.
Yes. Completing the squares. Okay, so complete the squares.
It would be -2. Well, if we divide it by 2, it would be -2. And then if we square it to -2, it would be 4.
So add a 4.
To both sides.
And for the y?
It'd be +9 to both sides because
+9.
Yeah.
Okay, so what is the equation of the circle?
It's a -2 or -2 squared plus y plus 3 squared and then plus 9 or just 9.
Equals 9.
Mhm.
So then the first center is?
The first center is 2, -3.
Okay, now do the same for the second circle.
So it would be x plus 3 squared.
X plus 3 squared plus?
Y plus 2 squared.
Okay, so you added a 9 and a
4.
4.
So it would be 4. And then it would be at -3, -2.
-3, -2. Okay, so now you want the equation of the line. So to find the equation, and we're going to go over this again in chapter 3, to find the equation of the line passing through 2 points, which in this case are 2, -3, and -3, -2. The first thing you do is find a slope. What's m?
M is y, what was it? Y plus.
y2 minus y1.
Oh, that, yeah, y2 minus y1.
Right.
And then it'd be x2 minus x1.
Yes. So it's a change on y over the change in x. So what is that equal to?
So that would be -2 minus -3. And then negative, or not, yeah, so -3 minus 2.
Yeah.
And then that would get us 1 over -5.
Okay. And the second step is to apply the Poynter formula. Y minus y1 equals m, x minus x1. So you get?
Y minus y1. But wait, so y, y1 would be -3. Or what are we doing here? Exactly?
So you can call, let's see, you did call, so it's -3, 2. So this is your x1, y1, I think, right? And this is your x2, y2, because you get -2 minus -2. Okay, so you can use the same x1, y1.
Okay, so it'd be -2 And then the other one would be would, so that'd be 1 over -5.
Negative 1 over, or negative 1 over 5
Okay.
times
And then
x minus
x minus -3.
-3. And then just simplify that.
And simplify that. We would, yep, divide or subtract 2 from both sides. Or,
Subtract 2. Let's multiply, open the parentheses on the right side first.
okay. So it'd be negative 1 over 5x. And then it would be negative. Let me do this real quick.
3 over 5,
Oh, yeah, I guess. Yeah.
right? Yeah. Okay, now you can subtract that 2 on both sides.
Mm.
And then you have to do LCD.
So
Negative, yeah,
-2 would have to be multiplied by 5, and then that would be -10.
yes.
So, and then we would subtract it, or what are we doing? Yeah, we would subtract it, so it would be negative.
Both of them are negative.
So it'd be -13 over 5.
That's right. There's your equation.
And then that's what I would write for the answer.
Yeah.
Can you make it smaller so I can fully take a screenshot really quickly as well?
You know that you have access to all the class notes.
Does this go into the class notes as well?
Yeah. So
Oh,
everything that I do here in Notability, it gets uploaded to that Google Drive.
oh, okay. I didn't know that.
Yeah.
All right. And then I had one last question. It was more of I didn't have the equation for this. So it was, if the circumference of a circle is 6 pi, what is the radius? And I searched up what a circumference would be, and it gave me 2 pi r.
Yes.
So what I did was 6 pi equals 2 pi r,
Yes.
and then I just divided both sides by 2 pi,
Yes.
and then I got 3r. Or is it 3
R
pi
equals
r equals 3, or is it 3 pi? Oh, okay, so
no,
it's just 3.
because the pi is canceled.
Okay,
Yeah,
Right.
that's the radius.
thank you very much.
You're welcome.
That was it
Okay,
for me.
so have a good long weekend. I'll see you Tuesday.
And then for submitting the homework, does it have to be in a file, or can we submit multiple photos?
It has to be PDF in a single file.
All right.
Okay. Thank you.
Have a good weekend. Liz.
Right.
Okay.
Where do I find those that Google Doc?
Where do you find what?
The Google Doc that has all the things.
Oh, the class notes?
Yeah.
Here, let me show you. So you're gonna go to Canvas, home page. Okay, so on the top of the page, lecture notes. Do you find it?
Yeah.
Okay, so you just click there and then you'll go to the, it'll take you to that Google Drive. And they are labeled by date. So today is, so I haven't, once I close it, then the September 1st, you see right now there is nothing, right? Just that. But once I close it, it will upload it. In fact, let me do it right now.
Okay, I think your mic got cut off, but I'll see it.
Okay, so that's it. So did you find it?
Yeah.
Okay, very good. So I'll see you Tuesday then.
All right.
Okay. Oh, stop recording.